Welcome to the next lesson in the straight line, which is called collinearity. And in this one, we'll be looking at whether 3 points in a line are collinear, which means basically in a straight line or on a straight line with each other. And remember this word collinear because you'll need to be able to make a statement at the end of the question to say whether or not lines are collinear. So let's think about this for a second, okay? We'll go over to the side here. And we will try and draw a straight line and see what happens. I knew that was going to happen. So if we've got a straight line, and if we have 3 points in that line, there's A, B, and C. And there we go, A, B, C. These points are said to be collinear because they're in the same line, one after the other. Let's think about this in more depth for a second. Look at between A and B and between B and C. If it's the same line, you can see that basically these 2 points, they have the same gradient, or these 3 points, sorry, have the same gradient as each other. And also we have this point in the center. So what I'm saying is this gradient here might be 2, and if it's collinear, the gradient here will be 2 as well, because you can see it's a straight line, so they'll have the same gradient as each other. The point I was making there about B is that B is a center point, and if we use A and B and find the gradient, and we use B and C and we find the gradient and they're matching, we can therefore say, since the gradients are the same, they are parallel, and because we used the common point of B, it means that they are collinear. So let me run over that one more time. Clear up some of this mess. Okay, so you've got the point A, B, and C. We've got a line joining them and a point in the center. And if we use the same point and we get the gradients for these 2 lines coming out identical to each other, then we know that these 3 points are collinear. What about if we just talk for a second about a line that wasn't in the same path? If it come over here, think about that. Let's get rid of that for a second. If the line went up and then bent off like that, and we had the point C down here. Well, that second gradient there is not going to be 2 anymore, so the gradients will not match. This gradient might be something like a half. Therefore, they are not collinear. These lines are not collinear now. So the second that we know that the gradients don't match, we can say that these 3 points are not collinear. So here's what we're after. We're going to work out the gradient between the first 2 points. We'll work out the gradient between the second 2 points. And so long as they get a point in common and we get the gradients being the same, then we can say that they are collinear. Now, I'm going to put wee asterisks down here because there's a statement. There is a statement that needs to be made, and we'll talk about that in a minute, but it's very, very important that the statement is correct. And we'll talk about the 3 things you have to mention. And I'm going to write them here. Please remember these because it's very specific to the end of the question. The wee statement you have to make has to mention the following things. So the first thing is you'll have to mention that the gradients are equal, or if they're not equal. Gradients are equal, that means that they are parallel, P-A-R-A-L-L-E-L. Secondly, you need to mention then that you must state the point they have in common. Okay, you have to actually state which point it is. So the point A is the point in common, and then obviously, therefore, you have to mention the words collinear as well. Okay, so gradients are equal. That means that they're parallel. You must state the point, actually mention which point it is. In this case, the one we were looking at here, this example would be B is the point in common. Therefore, they are collinear. Okay, so 3 things. Gradients are equal, mention the word parallel, Because there's a point in common, state the point, then they are collinear. Very specific, you need to mention those things. Okay, we move down. Basically what I was talking about there is the next part in the notes. The gradients are different, the points are not collinear. Yeah, there we go. The test for collinearity can only be used in 2 dimensions, so we're not going into the 3rd dimension with this, it's just 2D coordinates. And because the gradients are not the same here and here, it means they are not collinear. So remember, you've got the inverse to deal with as well. Right, so the first question, and I'm going to just alter this a wee sec. Okay, I can't, never mind. So we're going to show the points are collinear. So the first thing we'll do is we'll find the gradient from P to Q. And of course y2 minus y1, so that's 2 minus negative 1 over 0 minus negative 6. That's 3 over 6, that's going to give us 1/2. Okay, now we're looking for the gradient of this other one between between Q and R. We're going to use y2 minus y1 over x2 minus x1. We're looking for this to be a half as well. That's 4 over 8, and there we go. Because the gradients are the same, so our statement then is, since MPQ equals MQR, lines are parallel, we're going to mention the point, and it's as Q is a point in common, lines are collinear. So mention that the gradients are equal, that means that they're parallel. Q is the point in common, therefore lines are collinear. You can use the 3 wee predator dots, therefore lines are collinear. Okay, 3 things, 1, 2, 3, in the statement at the end. Nice wee question these are, hopefully we get some to deal with this year. Okay, shifting on to question 2. 2, here's one to really watch out for. We're told that they're collinear. We've got an unknown value, we have to find the value of k. We can use the fact that they are collinear to say that the gradients are equal and then solve an equation. So let's go for that now, very carefully. The first gradient is going to be k minus negative 1 over negative 1 take away 1. So that's going to be k plus 1 over negative 2. The second gradient is going to be y2 minus y1 over x2 minus x1, which is going to give us 7 minus k over 6. We're going to go and set those equal to each other. K plus 1 over negative 2 equals 7 minus k over 6. A bit of cross multiplying, like from the sine rule back in National 5. K plus 1 equals negative 2 brackets 7 minus k. That's going to give us 6k plus 6, negative 14 plus 2k. And if we rearrange that, we'll get 4k equals negative 20. We get k equals negative 20 divided by 4. So k equals negative 5. Okay, watch out for that type of question with an unknown value that you have to find because you're told that they are collinear. Find the gradients, set them equal to each other, and solve a wee equation. Shifting on to this question here, the points aren't lying in a straight line, calculate the value of k. Same deal. If you want to pause the video and have a go at this question, I'll be back in a second with the answer. Okay, so we're going to find the gradient AB. Three quarters. Going to find the gradient BC. 12 minus 8. That's k minus 8 over 4. we know that because they are, does it say they lie in a straight line? Okay, that means that it's collinear, they lie on the same straight line. We're going to set them equal to each other and go from there. I'll go below. Take my time with the k. Minus a over 4 equals 3/4. So I'm going to times both sides by 4, which is going to bring me up to k minus a equals 3. So k equals 3 plus 8, which is going to give me 11. So we get the value of k coming out as 11. Just be careful, it might ask you to state the coordinate at the end, but it doesn't, just says calculate the value of k, and that's what we've done. Shift on to this question as well. I'll give you a wee second to try it. Okay, so same again. 13 minus 10, 2 minus 1, 3 over 1, 3. That was for ST. And the gradient of TU is 16 minus 13 over T minus 2. That's 3 over T minus 2. Just be careful, it's on the bottom this time. I'm going to sort that. T minus 2. We can set them equal to each other, and we'll go 3 T minus 2 equals 3. We've got a cross multiplying or times both sides by T minus 2. We'll get 3 equals 3 brackets T minus 2. That's 3 equals 3T minus 6. Expand the brackets. Maybe get 3T equals 9 and T equals 3. Okay. Another one here. Have a go, and then I'll be back in a second. So this one brings in midpoints, as you can see. P is the point and M is the midpoint of PQ. Q is 8.4. Then we have to find, or to show that RS and M are collinear. So we're going to need the midpoint. So we're going to go for the midpoint first of all. Remember, you add the x's, add the y's and half them. That's going to give me 9, 0. I'm also just going to write down the 3 points that we're dealing with then. That's R is 1 minus 6, M is 9, 0, and S is 13, 3. So it says it's the midpoint of PQ. And we're going to go for the gradient between RM, and to save us a bit of time, that will come out as 3/4. The gradient of MS, that's going to come out also as 3/4 if you've done this properly. Our statement then, because we've got the two gradients matching, we have the point M in common, we're going to say lines are parallel as M of RM equals the gradient of MS, and since capital M for midpoint is the point in common, RMS are collinear. So there's a wee bit of leeway, but not much on this statement. Lines are parallel because the gradients are the same. The point M is the point in common, and then the word collinear has to appear. So a bit of practice on that. Okay, here's an extension question. Okay, so last question in these notes, we're going to use the count on method for this. We're going to find the distance horizontally and the distance vertically, and then we'll use the ratio 1 to 2 to get the point C. So over here on the right hand side, we'll do 19 take away 7 to get a distance of 12 vertically. Horizontally, 9 take away 3 is 6. Then we have to realise that the distance is 1/3 of the way up. So if we go 1/3 of the way along and 1/3 of the way up, we can get the coordinate point. So 1/3 of 6 is 2, 1/3 of 12 is 4. So along 2 up 4. If the point A is at 3, 7, we'll go along 2 from that to get to 5, and we'll go up 4 from 7 to get to 11. And that gives us the final point of C is 5, 11. Okay, any questions, ask your teacher or get in touch through the Teams page. That's the end of this lesson. Let us know how you get on.